Welcome to section 8.4, Graphing Rational Function. Before we get into the graphing part, I want to talk about the mechanics, the aspects for a graphing rational function. The first part I want to cover is horizontal asymptote. Horizontal asymptote is a dotted horizontal line that you would make to determine your graphs. A horizontal line is where the graph mostly doesn't cross, doesn't touch. So again, we're just going to talk about how to find a horizontal asymptote in order to graph our horizontal dotted line. And again, this horizontal dotted line will help determine how to make your graph. Now, let's talk about the three types. Here on the left side, I wrote numerator degree, meaning the numerator highest exponent. And then here, denominator degree, meaning the denominator highest exponent. So if we look at the first part, if the numerator degree is higher than the denominator degree, therefore the horizontal asymptote, there will be none. You will not have any horizontal asymptote whatsoever. Now the second part, numerator degree, if it's less than denominator degree, then for our horizontal asymptote, it's going to be y equals 0. So you would just write horizontal asymptote y equals 0. For the third part, if the numerator degree, if the numerator highest exponent is the same as the denominator degree, the denominator highest exponent, therefore our horizontal asymptote is y equals numerator LC, which is leading coefficient, over denominator LC. So the leading coefficient is the number that's always in front of the variable with the highest exponent. So I repeat, the leading coefficient is the number that's in front of the variable that has the highest exponent. So make sure you have this written down in your notes, and then we're going to work on an example on identifying horizontal asymptote, then transition into finding vertical asymptote. Now in our first example, we have a function f of x equals x plus 2 over 3x minus 9. So first thing is we're going to look for horizontal asymptote. So let's take a look at what we see here. So if we look at the numerator, our highest exponent with the variable is 1. So my numerator degree is 1. Then let's take a look at our denominator. The highest exponent in the denominator with the variable is also 1. So I'm just writing this step by step. So you can see here that numerator degree is 1 and denominator degree is 1, therefore they are equal to each other. If they are equal to each other, then it's going to be the leading coefficient. So horizontal asymptote is y equals numerator leading coefficient over denominator leading coefficient. So let's take a look at our coefficient. In the numerator is the invisible 1. So basically it's going to be y equal 1 on the top, and then on the bottom in the denominator it's going to be that 3. So I'm going to put 3. And it's positive. So in the event if it's negative, be careful with that. Make sure that you carry down the negative. In the event it is negative. But here it's just positive 1 on the top, positive 3 on the bottom. So my horizontal asymptote is y equals 1 over 3. And I'm stating that this is our horizontal asymptote. And let me box that up. So that's how we would find our horizontal asymptote, is you double check your degree in the numerator and your degree in the denominator, compare them, In this case, you can clearly see that they are equal to each other, so I'm using the rule for horizontal asymptote, numerator leading coefficient over denominator leading coefficient. So as long as you have those rules at your side, you should be able to determine horizontal asymptote. Now, let's talk about, for this one, our vertical asymptote. So after you finish finding horizontal asymptote, we're going to work on finding vertical. So before we start on the rules for finding vertical asymptote, this one here we're going to factor. In my numerator, x plus 2, there's nothing you can factor, so you leave it alone, meaning it stays the same, so x plus 2. Now in the denominator, 3x minus 9, that one you can definitely factor. I'm going to factor out to 3, and I'm going to have inside my parentheses x minus 3. So this is the factor form for this function. Now for the rules on finding vertical asymptote is step 1, factor and simplify. What I mean by simplify is you divide common factors, cross out common factors. 2, after you factor, set denominator factors with variables equal to 0, and then solve for variable. So we did step 1, factor and simplify. I factor. There were no common factors for me to simplify, so this is what we have. Now we on to step 2, set denominator factors with variables equal to 0. So that means that in my denominator I'm setting x minus 3 equal to 0 because it has the variable x. So x minus 3 equal to 0. That was step 2. And then step 3, solve for variable. So I'm going to add 3 to both sides so I can get x by itself. So x equals to 3. I finish. And that was the only factor I have in this example. So I'm going to write VA, vertical asymptote, x equal to 3. And that will be my final answer. So as long as you have these steps on finding vertical asymptote, then you should be fine. So step 1, factor and simplify. Step 2, set denominator factors with variables equal to 0. And the reason I clarify factors with variable because in this problem you have two factors, the 3 and the x minus 3. And for step 2, you clearly want to focus on the ones that has a variable. So in this case, x minus 3, set equal to 0, just like how I did here. And then you solve for variable, like how I did here. And this is our final answer for vertical asymptote.